In this video, we're going to go over Maven 101 basics. You may be new to Java, you may be new to Maven, and what we're going to do here is try to break down the absolute basics of what Maven is and why we choose to use it and why it's been such a large part of the Java community for so long. So in this video, we're going to go over the basic project structure. We're going to talk about what exactly is Maven, why we need it, some of the very basics in terms of lifecycle overview and what that means. These might be things that you're familiar with in some other languages if you come from that background. We're going to go over, like I said, the basic structure overview, and what we're going to do is introduce Maven into a very simple Java application that we have, which extends actually from a previous video that we've done. I'll put a link in the description. So if we first take a look at what it is that is Maven. So here from Maven's page are Maven's objectives that they state, and you can read these, but the overall goal here is to provide a standardized way to put together projects, to build projects, to package projects, and to run them. Maven was introduced, I believe, in 2004. Prior to that, Java was an interesting place in terms of where projects how they were built, how they were run. If you were lucky, the project was using another tool called Ant. And even within Ant, a project could look any way the developers or that team decided to make it, because you could do that with Ant. There were really no boundaries. But Maven came along in 2004, and it built on top of some of the ideas of Ant in terms of a declarative way to structure your project and to have it be built. But it actually took it a step further in terms of laying out a project structure that's agreed upon that you must follow, and simple lifecycle rules. So let's get into what that means with the lifecycle rules. Typically in a Java project, you're going to have at least two steps, and more often than not more, which you're going to have at least a compile step and then probably some sort of package step, one way or another. You have to compile the Java source into bytecode, and then you need to package it probably into a jar format, Java archive format, to ship it, share it, execute it. And we were doing all of those things in Ant, or maybe through shell scripts, batch files, you name it. It could have been anything that was compiling and providing this process for any given Java application. And it was just the Wild West. And Maven came along, and we got a standardized lifecycle, which was nice. And they defined many of these phases that you can see here that execute in a specific order. So the very first one is the validate, and these are steps that you can plug into a project to, essentially the linting rules, if you will. In the Java world, we usually will call that check style, or you might do some other rules such as static code analysis here. And then Maven doesn't provide these by default, but there are plugins, many plugins available that you can add that provide this functionality. Next is the compile phase, and that will compile just your source code, the application source code of the project. Next is the test phase, which will compile and execute the test sources. And we'll talk about how it does that separately, and it has a lot to do with the project structure. And then is the package phase. There is then a verify phase, which you could run and plug in integration test frameworks to test against the package framework, the packaged artifact from the package phase. And then there are two more phases that are sometimes less often used. It really depends on the setup and how you're using this project, but there's the install. And what install does is it's not like installing some sort of package to your operating system. What it is it's installing your packaged artifact into your local Maven repository. This is something that I don't want to discuss at this time in this video, but it is something that is really critical when we're talking about dependency management and build libraries and with your project in Java. And the Maven the Maven repository is a directory local to your file system. It's usually local to your home directory. And this is a place where all the shared libraries and plugins are stored so that they can be reused and cached locally, if you will. So the install takes your package and installs it into that location locally. Many times this is not required, depending on, it really depends on your application. If you're trying to share a jar locally that you're building with another project that needs to pull it in and use it, this is what you would need to do, is perform the install. But generally speaking, this is not something that is required for a standalone project. And last is the deploy. This is more often than not, I mean, by default, this means something specific to Maven, which is to push and deploy your packaged artifact that you would have installed in the previous phase locally. This is to deploy it to a remote Maven server. It could be a local server that you're running in your own data center, or it could be a public repository. Again, this is usually only required when you're sharing API libraries. So any sort of shared jar that you're wanting to use and leverage via Maven is something that at some point along the way had gone through this Maven deploy phase. But for your own project, this may not be something that you're doing yourself. If you're just packaging an application that you're just executing in your own environment, the deploy isn't necessarily something that you're going to be needing to do. So now we've talked about the basic phases of Maven. Understand that within each one of these, there can be specific goals that can be called, where different plugin goals can be tied to those phases. We're going to get into that shortly with how we execute our project. The next thing we want to talk about is the project structure. Now, in order for Maven to provide a consistent known build environment, it relies on some conventions, which you may be familiar with from many different programming frameworks available. With Maven, what we're trying to do is set up this sort of structure that they show here. And you may hear if you're new to Maven and you don't understand why the people chose the names that they chose, you're like, what is this source main Java, source main resources, source test Java? Why is it like this? Well, this is a Maven standard. This is the Maven convention. The ones that you're probably going to be most familiar with if you're joining a new project that's Maven or you're starting on your own, the ones that you're going to care about the most are going to be source main Java and resources, as well as the source test Java and resources. These are the critical directories that you're really going to need in any given project for your source files and configuration and test files and configuration. That's where those go. As far as the other directories that you see here, they may or may not be needed in your project. More often than not, you will not find the source main filters or source test filters these days. This was a technique used in older projects to, at build time, filter in various configuration into your packaged artifact. Prior to the concept of build once, run anywhere, which really was the promise of Java all along, many organizations were using tools such as Maven or maybe homegrown tools to package our artifact differently with different configuration based on the environment or where it was going to run. That was actually common practice many years ago. And these filters directory in Maven really help facilitate that feature. These days, you're not going to find people wanting to do that so much, because we really just want to package our code one time and configure it from the outside and run it in different ways than we used to. So these are, in my opinion, just an older way of doing things in Maven that you may not find in newer projects these days. Source main web app, again, depending on your application type, may or may not leverage this. In a traditional J2EE Java project with a web XML and JSPs, this is where those artifacts would go. They would go into the source main web app directory. If you're using more modern frameworks such as Spring Boot, which many people use these days, you'll find that you may not need to use that web app directory anymore. It really depends on what it is you're trying to accomplish. And the only thing that's really important about this is that in Maven, when it packages this up, it just places it into a different directory in the target output. Again, this isn't so important with most modern projects, but it's important to know that it's there, especially if you're dealing with a more legacy application. And last are the source IT. Again, it says here, this is specifically if you're developing Maven plugins. Probably not going to apply to you, at least if not if you're watching this video. Not right now, at least. Stay tuned, we'll get there in future videos. As here is the source assembly. Again, this is a little bit more of a legacy artifact in Maven. This would provide the ability, and I've used this before in the past, this would provide the ability to have a custom packaged deployment. So by default, Maven will package your artifacts into a jar file, which is great most of the time if you just have a simple Java application or an API that you're trying to share. However, sometimes you have a more complicated package that you need to produce. Maybe it's an actual install file. Maybe it's a Windows installer. Who knows? It could be something that Maven doesn't understand how to do by default. The source assembly directory is the place where you would place more XML files, and Maven is primarily driven by XML. More XML files to describe what the end result assembly looks like. It has very similar syntax to Ant in terms of copy these files from these directories, place them into this target directory, zip these up into a zip file, whatever you're trying to accomplish. This is what this would be used for. Again, these days, probably not something you're going to run into very much. And last, we'll find the source site. This is a really interesting and powerful part of Maven that you don't really find a lot of people spending the time to do. In fact, if you look at this documentation here, this was generated by a, I believe this one was generated by a Maven site descriptor, but it may not be. Essentially, it is a way to provide documentation and automatically generated HTML from your project. It may not be the prettiest thing in the world, but it is a way to, and we won't go into that in this video, but it is a way to essentially tell Maven to generate a site, if you will. It's a documentation site of HTML files that describe your project. But today we're just primarily going to be focusing on the source main Java and resources, as well as the source test Java and resources. So let's take a look at this very basic project that we have here. And in a previous video, this is more or less where we left off. It is a very simple Java application that we started in IntelliJ. In this case, we have a source directory and a test directory, and it is compiling the output on its own into some directories that IntelliJ chose by default. You'll find in that out directory here. And we can also run it. It has a simple greeting, and it's pretty straightforward. The problem we have right now, though, is that this application, without myself writing some sort of shell script or remembering a bunch of commands, I can't simply compile and run this application without my IDE. And although I love the IDE, it is very powerful, and I think that if you're working in Java, it's a no-brainer that you should be using one. I don't think that we should rely on them to always be the thing that packages and runs our application. It can get into a really sticky situation, especially if other developers are relying on a different IDE and they choose to use a different IDE than what you choose to. I choose to use IntelliJ. I've used Eclipse in the past. I love them both. This just happens to be what I use today, but I would hate to work in an environment where I can't choose to use IntelliJ because someone made all of their build scripts specific to somebody else using Eclipse, for instance, or NetBeans. So what's important here is we want to build a way to compile and run this anywhere on any machine, regardless of which development environment that came from. And as this project stands right now, we don't have this. So what we want to do is we want to introduce Maven into this project. But what we can see right away is that the project structure just simply doesn't work. It's not what Maven is expecting. And let's go ahead and show what that looks like if we just start off building this project as a Maven project. The very first thing we're going to need to do is create a Pom XML file, a pom.xml file. This is something, if you're familiar with Maven at all or heard of Maven, you've most certainly heard of a pom.xml file. But if you haven't, this is where it all begins. This is where it's all defined. This is how you define your project's build with Maven. And what we need to do, and forgive me as I kind of stumble through this, but we're just going to work through it on the fly. You have to define some basic structure for it to be a valid Maven file. So what we're starting off with is simple XML with project, telling it the Maven model version is 4.0.0. I can't remember the last time that changed, to be honest with you, but that's what we have to at least specify. In Maven, there's also this whole set of coordinates, and I would like to take we'll have another video to go over Maven coordinates, why they're important and what they mean at another time. But at bare minimum, you have to specify a group ID, an artifact ID, and a version, which becomes the Maven coordinates of this project. So for a group ID, we're just going to say blended software. The artifact ID is usually the project name. We're just going to call this example. And a version, we're going to call 1.0.0-snapshot. Now, you may or may not know the -snapshot in Maven is actually very important. It's a special suffix to a version name that tells Maven that this particular project isn't done yet, so that this really becomes important when you're performing the deploy that we talked about earlier, pushing your project to a remote repository. In those cases, when the -snapshot is there, it instructs Maven in the repository to know that it's okay to overlay a new version when it's updated. That's how it knows that this is updating. It also is the trigger for the downstream clients, which we'll get into dependency management in another video, but it does trigger downstream clients to know that they need to check for new versions, new snapshot versions, and if available, pull them. So that is a very special suffix in the Maven world. So we're just going to go ahead and do that. It would leave the -snapshot because this is, of course, a influx project. And this is, I believe, more or less all we need. So if we go into our command line now, for this project, in the root of here, we should be able to run a very simple Maven command. We should be able to say Maven Compile and see what happens. So it says it succeeded, which is great. That means that the XML here, bare minimum, is good enough. But let's take a look at what happened, because remember, we did not move our source file or our test file. It doesn't meet the Maven structure. So what actually happened? Well, if we look, we're going to see it went to the default resources phase, looking in source main resources, and found nothing because the directory doesn't exist. And then it also went to the default directory, source main Java, which you don't see it pointing out here, but it found no sources to compile. So essentially it did nothing because it couldn't find the file. So what we need to do is move things around, create a couple directories. This is usually not that big of a deal. In order to make my life easier, I'm actually going to instruct IntelliJ to unmark these as sources root and unmark these as test root. We will fix this later when we re-import. We're going to re-import the project as a Maven project in a short while. So let's fix the project structure. So now we have a source main Java that we can move our app.java file into. And then we need to have a source test Java. Create a new directory. Move the app test underneath. And now the directory structure looks better. We just have moved those files into the correct corresponding Java directories, and they do not have a package yet. They don't have a Java package. They're just in the default package. This is not recommended, but for simplicity's sake, this is what we're doing. Let's go ahead and remove these class files that IntelliJ was creating for us, because we won't need them anymore, and I'll show you why. And now let's try the Maven Compile again. This time you'll see that it actually found our code, and it found one source file to compile. And it compiled without any issues, so that's really good. Now let's take a look at what actually happened. You can see that it compiled that source into a new directory called target classes. Now IntelliJ before was compiling, it just picked a place on its own. It was picking a place out production example. I mean, that's great for IntelliJ and this local development, but not so great if I was trying to build a script for maybe somebody working on IntelliJ and somebody working in Eclipse to do a compile and run. It'd be better to rely on a command line tool such as Maven to do that for us. So now we at least have the compile step able to execute regardless of which IDE we're using. And if we take a look, we'll find that a new directory showed up in our project called target with the classes, the class output, and then some metadata that is important for Maven that we won't look into because it's not relevant here. But if we go back to the command line, all we did was the compile phase. For instance, if we go back to the build cycles, we only told it to go this far into the phase. So this time what we want to do is go a little bit further. I want to go to the package phase and see what happens. So we're going to tell it to not only compile, but to test, compile the test, run the test, and then package us into, let's see what it does, right? So this time if we look at the output, we'll see that it didn't need anything to compile because the classes were up to date. That's because it actually cached and knew that the compiled class file from before was there. If I wanted to make sure that this was a clean run, I could have added an additional goal to the Maven command, Maven clean package, and it would have cleaned any of the build output. Essentially, it removes the entire target directory. So it removes all of the build output that would go into the target directory so that everything can be regenerated again. In this case, I didn't do that. And so you can see that it knew there was nothing left to compile, and it just moves along much faster. When we get to the test phase, we now find it found our test classes to run, which is great. And now here's something that's new and surprising. It automatically executed the tests. Now I knew it was going to do that. So the test file that I had in place was actually conforming to JUnit standards because Maven by default will include this Maven Surefire plugin to execute the test phase for us. And by convention, it just looks for any Java classes under this directory. It will compile them, and it tries to run them with the default JUnit runner. And in this case, it was able to find this class, compile it, and run it, and no problems. It executed just fine. So now we move on to the package phase, and we could have enabled some more debugging output, but we didn't. The short story here is that it now created a jar file with our compiled classes. So this is really nice because prior to Maven, you would have had to write shell scripts like we said, or use Ant, or come up with some sort of custom way to your liking to perform this operation. Now, with hardly doing anything other than describing a very simple Pom XML and moving our code into a base project structure using the source main Java, source test Java, you can see that we've already gained quite a bit, which is a standard way to compile this application, test this application, and package it on the command line that will really work from anybody's machine. So that's already gotten us a long way. But what about running this application? So before we could just right click and run it, but that's not going to work anymore. So let's go ahead and see what it takes to run that now. What I know is that Maven comes with, and you will find this as you go through your Maven journey, that there's many plugins out there, and with a lot of more modern tools, and we'll get into those videos later, such as with the Spring Boot application, and I'll continue to reference Spring Boot because it's so prolific in our world. We'll get into that. It really does cover a lot of these for us automatically, and we'll talk about how it does that and why it's important to know these things with Maven in later videos. But for now, we're just going to skip ahead, and I'm going to show you the fact that there is an exec plugin with Maven. So you can tell Maven to essentially execute arbitrary tasks in arbitrary ways, but it does have a very special goal as part of the exec plugin, which is the Java goal. It knows how to execute Java, which is really handy. Now, unfortunately, as you can see already with this little bit of code that I'm going to I'm going to cut and paste with Maven, it's pretty verbose with XML. I would say that that's a bit of a downside to using Maven these days, but it still gets the job done in a very well-formatted fashion. And one of the positives that I actually do like about Maven is that because it's structured in XML, it keeps you and other developers from maybe doing things that are a little too complicated or recreating wheels that they shouldn't be recreating, because we can't just script arbitrary scripts in Maven as is. You have to do a little bit more work and you have to think about it a little bit more, which I think is a nice way to keep you from shooting yourself in the foot. So let's go ahead and take this base code that we have here and let's put it into our project and see if we can get this to execute our code. Now what I'm going to do is remove what I don't need. What you'll see now here is that we're explicitly defining the build section. Now this is part of the Maven POM structure. We just didn't define it because we were stuck with the defaults, and it knew what to do with defaults. Since Maven is a Java tool, it doesn't have to be for Java, but it understands Java natively. There's many defaults that are given to us, but now we're going to override some of the defaults, and we're going to introduce a new plugin, this exec plugin, and we're going to, using the same Maven coordinates that we used before, reference it by its group ID, its artifact ID, its version. We're going to tell it what to execute. In this case, we just want it to execute the Java goal, and then we need to configure it and tell it where our main class is. And now in our case, we don't have a package structure. We're just in the default package. So ours is just going to be app. We don't take any arguments to this application right now. We don't use any system properties right now. So we're going to remove those. And what you can see is we just introduced the exec plugin to our project. If we go back to the terminal, we should be able to run this now. So all we need to do now is perform the Maven exec Java command. And you see a little bit of Maven output, and then it gets to the exec goal, and you can see here is our output, the hello world. So now, not only do we have a standard command line based way to compile, test, and package, we also have a standard way to actually execute the output as well if needed. This can be really powerful as well for local testing, and just being able to spin the application up very quickly without requiring an IDE and the resources that go along with that. So these are the basics that I really wanted to cover here. One thing that you may be asking yourself if you're new to Maven is, well, how did you get Maven in the first place? Well, you can install Maven on every operating system as is, which I do have installed locally to this operating system. But I want to talk about one trick that's really important when working with a Maven project. It, in my opinion, should probably be the standard these days, but it isn't quite there yet. But there is something called the Maven Wrapper, and you'll find this in any new Spring Boot project that you generate. You'll find this in many projects, and let's take a look at what that is and what it would take to bring that into this project. So here's the Maven Wrapper, and since we already have Maven installed, so we're kind of cheating. But think of it as we're the ones that's going to set up life for other developers on our team to be a lot easier. Well, all we have to do is copy and paste this command. And I won't get into the specifics of what this is doing. But all we need to do is run that at the root of our project. And what it's going to do is download and set up a couple directories and a couple shell scripts into our project that we would want to share in our source control and share with other team members, because what this allows after this is done is now, instead of relying on, and this works for Windows and Linux, oops, make this bigger. Instead of relying on a local Maven and whatever version that happens to be. I happen to have 3.6.3, which I believe is the latest. We can use a local. If we look in the local directory, we now have a couple Maven shell commands, one for Windows and one for Linux or Unix operating systems. And what we can specify here now is what's powerful about this is we could be on another project, we could check out this code, work on this code, and not even have Maven installed locally to the machine. All we have to do is execute the local Maven wrapper, which is /mavenw, and we can ask the version of that, and let's see what happens. That's also 3.6.3, but if you notice, the Maven home distribution is actually in a custom directory specific to this project. Now let's take a look at why this is important. Well, one, we can provide Maven and something that's just going to work for other developers on our team right away, and that's really powerful. But secondly, we can actually control the version of Maven, which is even better, because I might have one version, another developer might have an old version or a newer version. But here, within our project, we can now edit this very simple Maven wrapper.properties and change the version of the jar that we want to pull. So 3.6.3 happens to be the latest, but let's say this particular project needed to run on something older. Let's say it wanted to use 3.5.1. To be honest with you, I'm not even sure if that's a real version, but we're just going to try it. So now if I go back to the command line in this project and I try the Maven version again, it didn't work. And I'm guessing because that version isn't available. But we could probably back this down to a 3.6.2. Imagine that that's something that's available. So let's go ahead and give that a shot. So now we do Maven W3. We get 3.6.2. You didn't see it download the new version. It must have already had that one cached. But what it will do if I don't already have that installed, it will actually remotely go fetch that, which is why you saw the previous one fail, because it was trying to go remotely find a version that didn't have locally cached and pull it, unzip it, and execute that locally for you. So you can see that could be very powerful as well, with just bootstrapping other team members to your project and locking down a very specific Maven version to execute your Maven projects. That's all I have for this particular video. Stay tuned for more videos on how we dive into Maven and all of the power that we have that available to us, and taking a deeper look into some of other tools and how they provide very deep functionality for us automatically via Maven. If you found this useful and like this video, please click the subscribe button, and we'll have more videos for you in the future. Thanks.